So what I have here is a video showing you how to use your calculator to solve. Um, I have a couple equations that you can enter in right now, and we'll go through and solve them. Notice I only have the first one highlighted. We're going to look at one at a time. So the first one is x cubed minus 3x squared, and you're going to graph it. And we want to just find the zeros, and then we could do things like find the derivative at different points so you know what you're doing with different features. So I have the equation in, x cubed minus 3x squared. If you didn't get that entered in, go back and watch it again so you can get those entered in. I push graph, and the first thing you want to check is your window a good window. And it looks like we can see all the turnarounds. We know it's a cubic. There's a max, there's a min, and then there's two zeros. It looks like the zero is at 0 and one of them is at 3. You can test it. You can go to your table and you can verify. So I see that they're there. My table's set on whole numbers. So they are there. But let's pretend we didn't know there. So we got to calculate zeros. So I go to the calculate menu and I want to calculate 0. And it says left bound. I want to enter something to the left. And I want to enter something to the right. And then I go back to it and make a guess. So 0, 0 is actually 0. If I wanted to verify, I could find the derivative at that point. I know the derivative there looks like it looks like a max as well because it's turning around, but I think there's a derivative there we could calculate. So you could calculate dy dx at 0 and see if it's a max or a critical number. And you enter the number and it tells you the derivative is 0. 1e to the negative 6 is 0.000001. It's basically 0. I want to calculate the 0 over here. Calculate 0. Go to the left. And you can either arrow over or you can enter a number to the right. So I could just enter a 4. I know that's to the right. And then come back just a little bit. Enter again. And it's at 3, 0. If I wanted to find the derivative there, I should get a positive number. And you can just enter 3. Say, what's the derivative at 3? It's 9. So if you actually took the derivative, 3x squared minus 6x, if you put 3 in there, you would get 9. Let's go to, that's a pretty easy function. Let's go to the second one and enter that graph. And this time I get a cubic, but it doesn't look like it's hitting values. We can check and see. Never assume anything on your calculator because you can't really see. So I definitely have a 0 at negative 1, but that's the only one I can see. I know there's one that happens between 0 and 1. So there's some things we can do on our calculator to help so that we can see that there's also one that happens right here. The best feature you have is your zoom box to be able to see your graph better. So if you want to zoom in to get a better picture, you arrow over and you hit enter, and then you make a box around the stuff you want to look at. And I'm going to take it all the way down to that low point. This is just going to allow a little more space to look at what we want to look at when we're trying to find the zeros. So I see it's between negative 3 and negative 4. So again, I calculate 0, and I want to go to the left of it. So you can't see the scroll, or if you know it's between negative 3 and negative 4, you could just enter it and you don't have to wait for the little spider guy to come back. But there he is. Hit enter, go to the right, hit enter, go on it, hit enter. Negative 3.791. It's probably a square root of some kind, and that's a 0. And you can do the same thing over here and verify that. A way that you could use your table, if you know it's between negative 3 and negative 4, you could use your table, go to your table set and start it at like negative 3.5 and make it go by small amounts. And then you go back to your table, the small amounts, you should be getting closer and closer to 0. You're between negative 3.8 and 3.79. If you want to find the value, you keep changing your table set to smaller numbers, and you start with the value you think is, I think it's at negative 3.79. And so I'm going to start there, and I'm going to go by 0.001. And so eventually you can get there this way, but it's a lot more guessing and checking. But this will get you closer. So now I know it's between 3.79. So at this point, if you want to change your table to ask instead of auto, now when I go to my table, I can keep entering values. 3.791. Like, okay, well, what about negative 3.7915? And you see, so it's in between there. I mean, it's a lot slower process than actually just finding the 0 on the calculate menu, but this also is another way to verify. Other things that are here, you can find your maxes and mins. We will find integrals. That's something later on. You could graph both of these functions and see where they're equal. In other words, you're solving, setting two functions equal to each other. Now I won't be able to see it. So I want to change my window back to zoom standard probably, but I can see two intersections. So let's go back to zoom standard. And say I want to calculate intersection. And it's going to say first curve, you hit enter, it'll jump to the second curve, you hit enter, and then it'll say make a guess. So you want to move close to the point where you want to make a guess, and you can solve the intersect at that point. You do the same thing for that one. And there may be another one way down here. If I want to see the one way down here, I have to change my window, and I need my window to show a lot more negative y values than it is. So negative 50, let's try that. It just stretches out the bottom of your graph, just like you were plotting points, not even close to enough. It looks like they're getting close together. We'll see if it is. Try changing that y again. I'm just kind of guessing and adjusting, hoping that I can get them to cross in my window. It's not going to happen. The last thing you could do is try zoom fit. Zoom fit picks a window. It's not usually a good window, and it's going to pick our original window pretty much. So you can see what happens is you lost all of your maxes and mins because they stretched out the y-axis, the window. But sometimes that's a good stretch, but look what it did with the window. It really stretched them out. So that's how you calculate 0. You can solve any equation by setting it equal to 0 and graphing it and finding the x-intercepts.